presentation on how to integrate Snort into Wireshark, and kind of as a side thing, how to investigate network IDS alerts. If you haven't already, let's go ahead and get Snort, Wireshark, and Oinkmaster downloaded, or at least get it started. And while it downloads, we'll go ahead and kind of walk through a few different things. So what we're going to do, if you've not used Linux before, just update the repository.
Does everybody see his screen?
Yeah, it's basically these two commands right here.
I see it.
To run. And then sudo apt install snort wireshark linkmaster and wget. You should have wget by default, but just in case, I had it on there because we're going to make use of that a little bit later. Then just hit yes, and that should kick it off.
Do you want to go over those commands one more time?
Yep. So it's going to be, I have it on the slide itself. Oops. It says sudo apt update and sudo apt install snort, wireshark, oinkmaster, and wget, just all as one line. So while that's downloading for everybody, I'm going to go ahead and just kind of get into it. One of the, I guess, benefits of where I live is I get gig internet, which is awesome, but I know it's going to get everything really quick. But so anyways, let's get started. Basically, what all I'm going to try and cover is just how full packet capture is typically done, what Netflow is, basically how do IDSs work, or like network IDSs anyway, the anatomy of the Snort Rule, some basic Wireshark. We're going to go over some like packet captures, and then also how to investigate IDS alert without a packet capture or a full PCAP. One of the things that you always learn in like SANS classes and other security type courses is, hey, here's a network IDS rule. Now just go to your full PCAP and investigate it. But the reality is I feel like most places don't have full packet capture. So we'll talk about that a little bit at the end of it.
If someone is doing an install of this, make sure you know what your wireless adapter is.
Yeah, so we shouldn't actually need to choose any
or your Ethernet adapter, either way.
Well, you shouldn't actually need that for this.
Snort does.
Well, even with Snort, we're gonna strip it out. I'll get to all that. Since we're gonna be using Snort in read-only mode, not actually sniffing traffic, we can pretty much just ignore that. But all right, so full packet capture. That's basically whenever you're capturing an exact copy of all of the traffic going in and out of the network. I included probably the worst diagram I've ever drawn over here to the left. Basically, the way it typically works is an organization will have a span or a tap port. A span is just a phrase, or I guess a term used in networking for whenever you're basically making an exact copy of another port. So for example, all of the traffic that's coming out of your port going out to the internet, you can mirror it or basically configure a span port to send that out to something called a sensor. A sensor is basically just going to be a server that's capturing the traffic. Some of the common ones are like, I believe it's ROC NSM, which is Network Security Monitoring, and Security Onion, which will basically allow you to do a full packet capture. And this is kind of a really, really extremely basic network diagram. So you'd have like all of your users going out to the internet, and everything that they do is being copied, or at least on the network level, is being copied on that span or tap. A tap is going to be a little bit different than a span. It's basically going to be a device that sits in line and mirrors traffic over to the sensor versus having to have a port dedicated to that. There are some benefits to it. Just for example, like you don't put any extra strain on the switch or router itself, just because you're basically using a physical device to copy that traffic. And it also makes your IDS a little bit more, I guess, disguised. Whenever you have a span or a network tap, assuming the attacker has control of the switch, they could theoretically see that you are doing full packet capture. and possibly even change, I guess, the config or what you're spanning to that sensor to make it so that you're not capturing their specific traffic. Basically, PCAPs kind of roll over. So something I didn't really know going into it, or going into working in an environment that does do full packet capture, is how it worked. If it was just one giant PCAP file, how you would go through it and pull PCAPs, that kind of thing. There's a few different ways you can do it. You can, of course, make it just one large file, but realistically, if you have a deployment similar to this one, you're probably going to set some commands that basically say roll over at maybe every 100 megabytes, or to roll over every 1 minute, kind of depending on your environment and how you want to set that out.
I will tell you that at the 1 minute mark, my packet captures from a university are a gig in size.
Yeah, no, I believe it. That's super common. So a lot of people just typically set like a specific file limit. So you'll, instead of having one big file, it'll be like packet capture for date, I don't know, whatever the day's date is. And then in that folder, it'll have every minute or every whatever file size you defined ahead of time, a different file with a packet capture for that, I guess, amount of data, if that makes sense. There are some risks to doing full packet capture. Everything that's on the network, like I said, is copied to it. So you have to remember, if that sensor or device does get compromised, everything you can see, the adversary can also see, and that can be anything from sensitive information that you don't want going across your network, or at least outside of your network, or just basically different traffic patterns. They can figure out what your kind of network map looks like, what devices and IP addresses are actually being used, a whole bunch of different things that you may not want them to see. And that's especially the case if you're doing SSL decryption. You have to be very careful whenever you do run full packet capture and kind of take that into account. With SSL decryption, you don't want to store or decrypt websites that are like banking or healthcare related, or even some that are payment related, because then you can be in violation of PCI, HIPAA, just whatever, you name it. So you really got to plan for full packet capture and make sure that you have it secured very well. But if you do have it, it's super helpful. Whenever you're investigating a network IDS alert, as you'll see whenever we get a little bit further into it, it's gold. You can kind of tell almost for sure if the network IDS alert is a true positive. It's going to be one of the only real ways to determine definitively when it comes to network IDSs that it was a true positive or a false positive on the match. So Netflow is going to be basically the summary information of full packet capture, or just the network traffic in general. It's going to include your source IP address, port, destination IP address, and port, the type, so if it's UDP, ICP, or ICMP, or TCP, and the total amount of traffic. And you can actually get a ton of good information with just these, I guess, items. So this is a screenshot of an Elk dashboard, just using their Netflow plugin. This is straight from the Elk website. And as you can see things like what all like destinations and IP addresses you're talking to, the autonomous systems. For those of you that don't know, these are going to be basically ISP assigned network range. Basically, you have to have this to peer, and it's a good way to identify who owns that IP address. So if it's Microsoft, for example, or Amazon, or maybe someone malicious. This isn't included in Netflow. This is something that Elk itself, which this program is going through and doing. It's likely just checking the IP address and then running some sort of script to pull that information into it, just as a FYI.
Yeah, you can do that with Whois as well.
Yeah.
And generally pull the AISN information.
Yep. And here's just another example of some kind of things you can do with Netflow data. So you can see what countries you're talking to. So if you don't really do any kind of business or anything outside the United States, or you don't have any kind of hosted IT infrastructure outside of the United States, or any vendors, it could be a good way to easily spot traffic that might be malicious within your network. That said, don't rely on that. Just because it's from China doesn't mean it's malicious, and just because it's from the United States doesn't mean it's safe. And of course, you can see who your top destinations are as far as like data being sent out of your network, how much data was sent, when it was sent, that kind of thing. And same thing with the ports. You can get a whole lot of good information from just having port information. So you can make inferences. If you see, I see a connection with a destination IP address of 80, well, you know that's going to be most likely HTTP. If it has a destination port 443, again, HTTPS. Never assume that just because something is over 443 or port 22, which is SSH, that it's encrypted. Always check it, because that could just be an adversary exfiltrating data, but either not having the technical know-how to have it encrypted, being lazy, or just a number of reasons. So always actually go through and check that traffic if you have the ability to. Don't just make any assumptions on it. So this is going to be a snort rule. It's good to learn snort rules for a lot of reasons. They're pretty much the standard for IDSs. If you're working with Cisco firewalls and you have their firepower, you're really just using snort in there. That's what they kind of run internally. They're almost the exact same format as a suricata rule. They're kind of the standard that you'll see when it comes to network IDSs. And to kind of break it down, there are different pieces that you can see in here. Within the header, you'll have an action. In this case, this one's set to alert, so it'll fire off an alert if anything matches the rule. You can also have some other ones like block if you're using it as an IPS, which is a prevention system. Pass, ignore, I forget all of them. Alerts generally the typical one that's being used.
One thing to note is if you're doing block or any of those types of things, you have to be in a tap mode where you're actually within the flow of traffic. Correct. If you're in a mirror mode and you do that, it won't have any impact. Right.
That's right. It's really risky to run an IDS, or at least at the network level, in IPS mode, or like actually inline doing blocks, unless you have a really well-tuned sensor. So you generally are going to run it as an IDS for at least a few weeks. And this applies to anything, not just Snort, so any network IDS. But you'll generally run it a few weeks in an IDS mode to kind of whitelist and tune it before you actually go through and put it in production if you are going to use an IPS. But anyways, back to the rule itself. So we have the action that we want the rule to take. We have the protocol, so the TCP, UDP, ICMP. You have the source address. In this case, we're going to choose any. This can also be a variable that you define in your snort config. We'll talk about that a little bit later. So typically, you'll see something like home net, which is going to be the addresses that you want to monitor, or external net, which is any address that's not part of the home net, or addresses that you specifically want to monitor as an external address range. Then you're going to have your source port, and then you define the direction of the traffic. And again, this will be your destination address. This could also say any or be a variable. And then the destination port. Again, this could be, these can also be variables, or you can define or more specify, just any port is fine. Then you go into the rule options. I should note everything in this header field is required in a rule. So if you're ever writing your own rule, you have to always have all of these fields. As far as the rule options go, you really only need these two right here for it to work. The message is going to be what the alert shoots out whenever it does detect it. So let's say we had an alert that triggered just off this rule alone. The alert would basically say message TCP packet is detected. That would trigger all the time. So you would never really want to use that. But that's the note that you'll get whenever it goes off. And then the SID, this stands for Security Identification Number. And this is going to be basically a way for you to document your rule. So if you ever see a SID and you're not sure what the rule itself is looking for, you can go through and search that SID on the internet. So like Snort SID X, and it'll pull up the rule itself so you can get an idea of what you should be looking for in that IDS alert.
There's also a range of SIDs where you can create your own custom, and so that you don't look up something and not ever find it.
Right. Yeah, I forget what that is, to be honest, off the top of my head. I have to look it up.
Oh, yeah, so do I. But it does exist out there, and it does allow you to write your own rules.
Yep. Okay, and let's see. Oh, it does not want to go to the next slide. Oh, I guess that was it. Like I said, or for those of you that weren't here ahead of time, I kind of threw this together basically after I got off work today. All right, so we have an idea of a Snort rule now. Let's go ahead and get Snort configured. Is everyone at a screen that looks kind of like this? If not, can you put it in Slack? And I'll just let Corey or somebody let me know if anyone says anything. I can't see it right now because of my screen configuration. But we're going to go ahead and hit OK on this. This is basically just saying, hey, we need to configure an interface for Snort to listen in on. For this particular, I guess, use case, we're only going to be using Snort read-only mode. So we can pretty much ignore this. You can just delete this out and hit OK. Okay, then this next screen, this is going to basically set your home net variable. Is something that I mentioned earlier. So you can see right here where it says home net. This is basically, think of this as the addresses that you want to monitor. So any kind of internal network address or address range, as you can see here, or depending on your sensor placement, if you have your sensor placed outside of your firewall, so it only sees your public IP address, you could put that there as well. Don't typically recommend doing that just because it's hard to correlate an alert back to a host that maybe triggered that alert. And you'll get a ton of false positives just from everything scanning your network, but sometimes that's the only thing you can do. For this, we're going to go ahead and just put in all of the private network address ranges. So the RFC 1918 ones. So we're going to do 10.0.0.0/8, comma, and then 172.16.0.0, and I believe this one's 12. Someone correct me if I'm wrong. Okay. Okay. Basically, once you're done with that, you should get a prompt about configuring Wireshark. It's basically just asking, should super users or root users be able to capture packets, or non-root users be able to capture packets? This is really going to be dependent on your individual environment and your individual company policies. The risk of letting basically regular non-root users have access to pull PCAPs is that if the machine that has Wireshark on it gets infected or someone takes control over it, they don't necessarily have admin or root privileges. This would allow them to start capturing traffic on your network. So you typically want to leave that at no. But again, it goes back to your individual use case. So either one will work. We're going to choose no for this walkthrough. It's going to go ahead and finish installing everything. If anybody has any questions or if I'm going too fast, let me know. While this is working, one thing to kind of know about Wireshark is that it loads your packet capture into memory. So if you get into big packet captures like Jeff was talking about, that could be a gig in size, you have to have at least a gig of RAM, probably more because of all your other services running, because you have to have enough memory to kind of hold that packet capture. So if you've ever opened a PCAP in Wireshark and Wireshark just closes, it could be that you just don't have enough memory to open it. So that's something to just kind of keep in mind.
And just piggybacking on that, something like T-Shark, which comes with Wireshark, can actually carve those into smaller pieces.
Correct.
So that you can look at them. So. Yep.
And TCP dump as well, if you are familiar with it. Okay. So everyone should be at this configuring Snort screen. If you're not, you'll get to it in a second. We're just going to leave this blank, so you can just hit tab and go to OK. Again, this is just asking you what interface you want to listen in on. Again, since we're just going to be doing or using Snort offline, we're just going to hit OK and ignore it. Okay, so that's done. Now we should have everything installed that we need to. Our next step is going to be to basically set our configuration options. So I had you install a few different things when we first started. So we installed, in addition to Snort and Wireshark, Linkmaster. This is a tool that's used to basically automatically go out and pull different rule sets. So some of the more common ones are going to be like the emerging threats, either open, which are the free set, or the pro rules, which are the paid set. Only difference between the two is I believe you get the emerging threat pro rules 30 days before you do as the open ones. So they're basically going to be the same. You just get the new rules a little bit sooner. And then wget is going to let us pull files from the command line. That should be installed by default, but just in case it wasn't, I had you run it again. Okay, so next we're going to go through and look at the configurations for Snort and OinkMaster. I've actually, prior to this, put them on pastebin to save some time. I'm going to kind of walk through them real quick. So this is the OinkMaster configuration. We'll get to where it's saved at in a second. The only thing that we're going to change into this is we're going to put the new rules that we want to download, basically uncomment a line in it and add those rules here, so that when we run it, this is where it's going to pull our rules from. Everything that has one of these hashes in front of it is not going to do anything. That just comments it out and makes it ineffective. So be sure to delete that. Where'd it go? Oh God, okay, here. Be sure to delete the comma in front of the emerging threats site whenever you're doing this in a real production environment, and then just add the link in question. The one that comes in here by default is outdated, just as a heads up. So you will have to get an updated link from the emerging threats website, but I've included it in a file that we're just going to wget here in a second. And then here is our Snort config. So this is going to be a little bit more in depth, and I'm just going to kind of go through it a little quickly, but if you have any questions, just of course, feel free to let me know. This is going to be our home net variable. This is what we configured earlier. Basically what it's saying is our home network, the networks that we want to monitor, are going to be everything in the 10 address range, everything in the 192.168 address range, and everything in the 172.16, I believe it goes to .32 address range. Everything else we're going to leave as default in this particular instance, but you can actually define other variables in here as well. So like if you know what your DNS server is, you can add the IP addresses for it, and then use the DNS server as a variable instead of home net. Same thing with SQL, Telnet. You guys get the point. And you can do the same thing with ports. So HTTP ports, you can define them, that kind of thing. So basically, for what we're doing, this is going to be the important one right now. External net is basically saying any address that is not the home net. Typically, these are going to be public IP addresses, but if you have an internal sensor kind of deep into the network to where it's only seeing other internal traffic, you could, in theory, actually do other internal IP addresses. So for example, maybe you have 10.1.1.0 network is going to be your external net to communicate with the 10.2.1.0. Let's get into the weeds a little bit. So but for right now, just note external net is anything or any IP address that is not defined right here. Then I'm going to scroll down all the way to the rules section. So by default, Snort has a bunch of rules and rule files within it. I've gone through and basically made a configuration file that we're all going to just download and replace our default ones with, just for the sake of time. Something that you'll have to go through and do manually is if you're not using these default rules in your environment, comment them out. Typically, I don't think these are as kept up to date as well as like the emerging threat rules. Though I don't know that for sure, but in this case, we're going to have them commented out. So none of these rules are really going to fire. And then we're going to add the emerging threat rules. So this whole section, you'll actually have to add manually. Like I said, I'm going to leave this pastebin. We're going to kind of download it and basically replace our configuration here in a minute. But I've gone through and added all of them for you. So basically, this just says the rule path, which is going to be the default one in our case, and to point to these rules and these rule files. So that's kind of the only changes that I've made in these two files. So what we're going to do is do a wget on these. So I wonder if it'd be easier for me to post these into Slack. Well, here we'll do this. So we're going to do wget here. So I'm going to change directory to documents. I can type. and do a wget paste. This is just the link in question. Do you guys see this thing right here?
Some of the pictures, some of the faces are in the way.
Yeah.
When you moved it up, it looked really good.
Yep.
Can you see it now? You still need me to move it up?
Move it up, please.
It's still blocked.
All right. Oh gosh.
That was good.
There we go. So in the documents folder, we're going to go ahead and wget this. This is going to be the snort config. That's just showing you that I downloaded it, the size, all that jazz. And then let's go ahead and get the oink master config. So again, we're going to wget paste here. Everybody get these? Okay, I'm gonna take that as yes. Again, wget. So you'll see that these actually have the file names of the paste bin URL. So we're gonna need to rename them. So basically what we're going to do is the snort one was the F85 one. So we're going to go ahead and just copy and paste that one into the, actually, you know what, let's do this just to make it easier. Let's just rename them manually. Let's go to documents, rename, change it to snort.conf, and just rename this one to oinkmaster.com. Everybody see that okay?
Yep, looks good.
Okay. So again, if we list the items in here, do an ls, we can see we have the two new files. So by default, at least on Ubuntu, this is definitely not the case for Security Onion or some of the other tools. The snort configuration is going to be, or is going to exist in your etc snort folder, I believe, snort.conf right here. So we're going to copy snort.conf and then paste it into here. So actually, we're going to cut and paste. So we're going to do sudo mv for move, snort.conf, and then we're going to put the path that we're going to paste it into. So we're going to do /etc/snort. And then we're going to do the same thing for oinkmaster, but we're going to do that into the etc directly. So ls etc/. So we can see the oinkmaster configuration is just in the etc folder. So we're going to do sudo move oinkmaster.conf to /etc. Now let's go ahead and just make sure that we have the correct configurations. So we're going to go to sudo, whatever text editor that you want to use. I'm going to use gedit since I'll be able to control it a little bit easier visually. Let's do snort.conf. It'll open up a text editor for us. And all we really want to do is, first off, check our home net variable, make sure it has the IP addresses that we set earlier. And then scroll basically all the way down to the bottom, and then make sure you see emerging in your rule sets. Once you've confirmed that, again, let me know if I'm going too fast. We're going to do the same thing, sudo gedit etc oinkmaster.conf. And scroll down and then look for this guy right here, emerging threats with this rule set. It's important that you have this specific link. Like I said, the original is outdated. Okay, so now that we've made sure that we have that, what we need to do is basically pull those rule sets from emerging threats that we just defined in our snort config. So I'm going to run oinkmaster -h. -h is just for help, just because I don't remember the flags very well. So basically, we're going to do an oinkmaster -o, which stands for basically output our rules, and then the output directory, which is going to be our rule directory. So by default, we're going to do sudo oinkmaster -o etc snort rules. And we're also going to do attack E. So this is going to enable all rules that are disabled by default for whatever reason. And I'm not sure why this is. Emerging threats does disable some of the rules in their rule files. So this will just make sure that all of them that we download are enabled. This isn't always what you want to do. In reality, if you do have Snort running in your environment, it's better to just use your internal rule set since that's what you're going to be looking for anyway. But just for the sake of this lab, we're going to enable them all because, to be honest, I didn't test any of the PCAPs that we're going to download, so this will kind of ensure that we get an alert. So again, sudo oinkmaster etc snort rules, and then E, or attack E. This is going to download them all and then output them to the rules folder. Once that's done, we're going to show that directory to make sure that they're actually there. Give it just a second for those that might still be downloading them. Okay. And as you can see, we have the emerging rule sets in here now. They all start with emerging dash whatever dot rules. And if you do want to actually look at some of those rules, let's do, would be a fun one. So let's do emerging, so sudo nano. Oops, that would be the typo. Oh, oops, gotta specify the folder. So this is going to be what a rules file looks like. And then here are your snort rules. Actually, let me open this in gedit so it'll be, I think, a little easier. Okay, here we go. Let me see if I can zoom in, and I can't. Cool. All right, so here's one looking for twitch.tv. Ooh, that's interesting. So this is Trojan IRC private message. So again, what this rule is looking for is this is going to alert us. It's going to look for a TCP connection. It's going to ignore anything that is not a TCP connection. It's going to basically say any address defined in our home network on any port that's communicating externally to any address that's not listed here, on any port that's not 666, and I think that is an OR. I'm not 100% on that, to be totally honest, which is why what we're going to show you later, or as the second, is going to be useful. But any port that's not 666 or 7000, alert on this condition. So basically, we have the message. This is what we'll see whenever it alerts. So all emerging threats rules and ET Pro rules will have ET to start them off. That's going to be emerging threats. The category, so Trojan, that doesn't necessarily mean that you have the Trojan, but that's what it's categorized as. Then, of course, what the, I guess, rule is actually looking for. So in this case, an IRC private message on a non-standard port. So this is saying the flow. This is basically saying it's the direction is to the server and the connection is established. Since this is TCP, it's going to be making sure that that three-way handshake did occur. So you have your SYN, SYNAC, ACK. Once that's met, then it will look for here. D-size, again, that's just basically saying less than 128. So whatever I do, whenever I don't know something when it comes to a snort rule, I basically just Google. And it was really straightforward. So let's see, D-size. So the packet payload size. Okay, so basically it's just looking for a packet payload with something. So a packet payload that's less than 128, I want to say it's probably bytes. Yeah, bytes. Okay. So if it's met all these, then it's looking for content. That's basically just a string in this case. So it's looking for this exact string. So priv message. Depth is specifying how far into the packet to look. And then content, this exclamation point, is basically saying if it's twitch.tv, we're going to ignore it. So the exclamation point ahead of time is saying not this. And then again, content, twitch.tv, again with exclamation points saying ignore anything from Twitch. Then it gives you a reference URL to look up the rule itself, or to get like comments. Sometimes you'll actually see links to blogs on why something is a rule. I don't see any here off the top of this page. And then again, it's got a class type, Trojan activity, your SID, the revision, so how many times it's been updated, then just some metadata, so when it was created and then when it was last updated. So that's going to be what an actual rule file will look like. And you can create as many rule files as you want. It's basically just a text file that has just text strings like this in it, and it's a .rules extension. And then as long as you specify in your Snort configuration the path to that file, you now have a rules file that you can use. So anyways, let's get to what we were really going to be looking for. So let's see. Let's go ahead and open Wireshark. So basically, the cool thing that I wanted to show you on this, and something that not many people even know that you can do, and something I didn't know you could do until just recently, there's like no documentation on this, so I'm still tweaking a little bugs, is integrate Snort into Wireshark. So if you have a Snort alert and you have the PCAP, rather than having to try and dig through the PCAP manually looking for an alert, it'll just tell you the exact, every single packet that triggered a Snort alert. So there are some kind of things we need to do ahead of time. Anytime you want to integrate Snort into Wireshark, you have to launch Wireshark as root. So we want to do a sudo Wireshark. The reason being is because for it to run Snort against the packet capture, it has to have root privileges. So you have to run it as root to be able to, I guess, do this kind of cool Snort trick. So next we're going to go to edit and preferences within Wireshark. We're going to click protocols, the little arrow to get the drop down. This is going to list all of the protocols in Wireshark that it has. So just scroll down to Snort. Let's see, where is it? Here we go. If you don't see Snort here, then you probably have a Wireshark version that's too old. You have to be 2.4.0 or newer. So here's what we're doing. If you're using something that's not the default installation path, so for example, maybe you're using some sort of custom distribution, whatever it might be, you need to basically point it to the Snort binary. For what we're doing, this is fine. This is going to be the default path for Ubuntu. You also need to point it to the configuration file. Again, this should have the correct path for that. Now we need to actually enable it as well. So right now it's not looking for Snort alerts. So we're going to be running from Snort. Got to be honest, I don't know what the user comments piece does. I've not been able to experiment with that and get it to work. Now we're also going to do show rule stats in the protocol tree. We're going to show alerts in expert info and try to show alerts in reassembled frames. Just go ahead and enable all three of those. I will tell you, and then hit OK, of course. I will tell you, whenever we go to open a packet capture, especially for large packet captures, this does delay the or basically increase the amount of time it takes to open a PCAP file. So if you've ever opened a big PCAP file that's like a gig in size, you'll probably know that that can take like a few minutes sometimes. So now let's download a PCAP of a malware sample. Just as a disclaimer, whatever you do with this, as far as the packet capture goes or the malware goes, you're on your own. But since it's in a PCAP, you shouldn't have to really worry about it unless you extract the executable and run it. So we're going to go to malware traffic analysis. I think it's .com. There you go. Close. So once you get here, we're going to go through and find some PCAPs. So let's see. Let's click here. Let's do, what would be a cool one? Let's do, really we can choose any of them. I'm going to just choose Sputnik House. I don't know what that is. Actually, you know what? Let's go back. Sorry. I feel like there's a better way to get samples. Here we go. Okay, yeah, let's do this. So go back to the homepage for malware traffic analysis, and we're going to go to the technical blog post and click 2018. This is where we get something cool and something that you might actually see in like a real world environment. So let's start with Imhotep. For those of you that don't know, this is one that's commonly sent in emails, basically to infect people that open malicious documents. It'll load the Imhotep malware, which can basically give people full control of your machine. We're going to download this.
It is an active malware. I was just dealing with it for the last few days. So that's actually one I know.
Yes. Yeah. So this could be something that you'll see in the real world. We're going to download this first file. This is the PCAP file. This one, I believe, is the actual binary. Don't download this unless you know what you're doing. But so we're going to download Imhotep right here, this PCAP file. It's a zip. We're going to save the file. By default, it should save in your downloads folder. Let's extract it. So we're just going to extract it here.
Just as a side note, if you take the PCAP and run it with a tool like TCP Replay, it will run the virus, so be careful.
Yes.
Use that.
Yep. Also, every PCAP on the site and every file on the site will have a password. That password is infected. I believe they have it on their site somewhere. It is.
And that's often used for many, many other places. So if you've ever gotten a zip from a malware person, it's probably infected, is the password.
And that's basically to prevent people from extracting it and accidentally running it. Okay, so we now have our PCAP in our downloads folder. So let's go back to Wireshark, go to File, Open, then let's go to Downloads. Here is the PCAP file right here. So we're going to open it. And like I said, there is a delay whenever you're running it with Snort, just because it does have to load a few more things. So it's going to take just a second. Well, it's taking a little bit longer than I thought it would. Oh, there it goes. Okay. I'm going to give it just a second for everybody else. Does anyone not have a PCAP open on their screen?
I'm there.
Okay. Well, I'm going to go ahead and just continue. If anybody has any questions or needs to help get into here, just let me know. Or type it in Slack and Corey or Jeff or someone can help you. But you can already see, here we go. There's our first Snort alert kind of built into it. This one is a very basic alert. All that this one is saying is that it's seeing an internal address, so like a 10.000, could be 192.168, whatever it might be. The reason that you might have something like this enabled is if you have some sort of weird network setup or you're monitoring at like a public address. I'm not actually too sure. You could definitely tune this rule so that if you see anything that's not in your monitored network range, still alert on it. But this one's going to be very loud, so chances are in a real environment you're going to have it disabled. But anyways, so if you click this little drop down, you can actually get all of the Snort information in here. It gives you the reference to a blog post on kind of what this IP address or what this kind of rule is looking for, as well as the rule itself. It gives you the actual raw alert. So we're seeing the SID, again, the SID, the rule message that we were talking about earlier, the classification, priority, all this jazz. And then you can actually expand it a little bit further. So this is what it's actually looking for. It's going to alert us on the IP address and any IP address in this range. But now for the kind of other cool stuff. You can see everything in this is going to be related to the Imhotep infection. That's just the way that the PCAPs on that site work. In a real environment, you're probably going to have a whole bunch of other addresses in here as well. So you may not be able to just open it up and be like, hey, I've got the full network traffic of my malware. So you probably will have to normally do some digging to find what you want. But typically, you're going to get your Snort alert. And let's say we want to go through and find this SID. So this one's 227.252. If this one was something that was a little bit more difficult to track down, in this case it's not, all we would need to do is just go to snort.sid equal, and then let's set the SID to 2002-752. Again, I'm getting that from right here in a few different spots. You would also get this to whatever you're viewing your Snort Alerts in. Then let's hit enter. And here are all of the packets that have that's SID in it. The cool thing about this compared to something like, I believe it's pronounced Squeal, which is another tool for identifying the packets that actually triggered a Snort Alert. Most of the tools that will show you the packet itself don't give you the full conversation, which makes it hard to investigate. So yeah, you can see that the IDS matched a signature it was looking for. That doesn't necessarily mean it's a true positive. So you might get something, there's a lot of really common, I guess, Snort rules that look for specific DNS queries. So anything ending in a like a .tk, like so if you go to whatever google.tk or something, if it has that .tk at the end, it'll fire an alert. So just because it found that doesn't mean it's malicious. But again, whenever you're using something like Squeal, you don't get that whole conversation. So a lot of times you can't tell. With Wireshark and this integration you do, so you could actually go through and follow this entire stream and get the full context around the alert itself. So I'm going to go back and just go back to Snort. So let's say we had a PCAP and we didn't have just the traffic. So we're looking at Wireshark. This is all the traffic. Let's say we didn't know which ones or which part of this conversation had Snort Alerts fire against them. Something you can do is you can just type Snort. It will show you all of the packets that had a Snort Alert with them, and then it will show you the Snort rule that triggered it down here in the protocol, I guess, area. I forget what this is officially called. So you'll be able to see what the rule was and just quickly get an ID or an idea of what rules actually fired. So yeah, we actually got a lot of good ones. So you can see like here's the Fiodo malware CNC group, so we could see what that was looking for. In this case, it's looking for any alert to basically any of these IP addresses. So this one was kind of a basic alert. We could really just open that up and then say, hey, search on any of these IP addresses and see if we found it. But so yeah, I mean, that's kind of it. So if you're looking for, or I guess trying to do an investigation on a Snort Alert with full PCAP, it's literally as simple as that. The cool thing too is if you're not using Snort, you're using Suricata. If you're using the emerging threats rules for Suricata, those actually use the exact same rules as Snort does. So while this doesn't have Suricata integration, if you are using emerging threats, well, there you go. You can just kind of put 2 and 2 together, just use Snort and go and find your Suricata rules the exact same way. Also, again, if you're using Cisco and their Firepower IDS, those are just Snort Alerts. They use, I believe, a special like Cisco rule set, but I think you can actually download those manually as long as you have or you're paying for a license. And then again, if you're using some other IDS, like if it's a Palo Alto or Fortinet or whatever it might be, Snort rules are so widely used, you would probably see those same IDS results in here. And even if you didn't, if you ran this on the PCAP you're looking for, it would give you basically another IDS to run against the PCAP that might catch something that your first one missed. So let's talk about investigating a PCAP, or I guess just investigating an alert where you don't have this integration, because unfortunately, not everywhere you work is going to let you fire up a VM with Ubuntu, load Snort on it, and oink master and rules and all that kind of stuff. So if you don't have that as an option, you really get all of the information you need to track down Snort Alerts in the alert itself. So let's see. How can I show this to where it'll make sense? Basically, let's see. Let's find an alert. So maybe let's go to Snort. All right, we're going to use this one. So let's say we got an alert that basically triggered on CNC command and control, Fioto tracker reported command and control server, TCP group 20. So if we had that alert, how would we investigate it? So whenever you get a Snort alert, it'll typically give you some information like the source IP and port, the destination IP and port, a timestamp, and I want to say that that's it. But that should be all you need. So let's assume that we got an alert for this. We would have the source IP address. So we could just do one of two things. We could do an IP.adder equal, so we know the source IP address 10.9.3.102. And again, instead of doing specifically the source or destination, I like to do just IP adder in general. That way I get both sides of the conversation. So again, equal. So 73, 125, 45, 48. And again, you would get this information from the alert that you received itself. So even though I could just see it right here, you would have this information if you're investigating the alert. And then if you, let's just say you need to get a little bit more specific, you could add the specific ports. In this case, we have a destination port of 80. So we could do tcp.dest port equal 80 and tcp.source port equal, let's see, what was this one? 52338. Enter. And again, you get all of this from the alert. That'll pull up the entire conversation between the addresses that we have. So now we would just go through with the information that we have. We would look for what this alert was looking for. In this case, it was basically just looking for any TCP connection that our home net tried to talk out to one of these IP addresses. So we look through and see if the IP address it fired on is in here. 73, 125, 45. Yep, it's this one right here. So we just found, yes, this was a true positive on that IP address. So we've confirmed now that the IDS alert matched a true positive for what it was looking for. Again, that does not mean that it's malicious, just that it matched a pattern for a signature that it had. So from here, we could go through and look at the entire conversation. So let's just follow the TCP stream and kind of see what exactly is being sent out. This will kind of take a little bit of know-how and to kind of have an idea of what you're looking for. You would have to do a little digging on this to figure out what is the specific, I guess, CNC beacon information. Since we just have the IP address right now, I don't have enough information really to determine if this is a true or false positive, but there could be other information in the PCAP itself. So now that we know that the host, or that we've confirmed that the IDS signature was a true positive, we can go through and just look at all of the traffic from the source host, the internal host that triggered the alert, to see what else it was communicating with. So let's just do an IP adder equals 10.9.3.102. You can see we have a lot of traffic out there. You typically are probably not going to go through and just manually click through each link. I like to personally go through and then sort all the DNS traffic first, just to see what kind of queries were made and IP addresses to them. But we can go through here and kind of get an idea of what all is being done on the stream. In this case, it looks like it's probably mostly gibberish, or maybe a document file that it's pulling down.
That .doc, part of that is the infection vector, okay, Microsoft cool. Documents. So
yep, here it is. Yep, so this is the Word file that it saw come across the network. And as you can see, we actually have a Snort alert for that, I believe, or we don't. Interesting. Sometimes you'll actually see a Snort alert for encoded like JavaScript or something to that effect actually in the document. And you'll see if, as long as you're decrypting the traffic or it's in clear text, an alert fire on that. In this case, it didn't. So here we do see the Word attachment itself. So we could pull that out if we wanted to.
I was going to say, can you do that?
Yeah, I'm not probably going to do that here, but if you wanted to, there's a few different ways that you could do it. So you can export objects In this case, it's HTTP. This will give you a list of all of the objects that were, I guess, included. So application MS Word, this is most likely going to be the document itself.
Yeah, probably the first one that they got that infected it.
Yeah. And again, you can see that payments is the name itself. It could be down here. You just kind of have to look, but I want to say it's probably this one. So we're going to close that out. And yeah, so I mean, that's kind of how you would go through and dig through an alert. You really have to kind of know what you're looking for, kind of understand the attack vector if you don't have the knowledge to look through the packet capture itself. So you have to get an idea of how does Imhotep work, what's normally delivered through a Word document, what are some of the things that it does whenever it does talk out. So in this case, we could see that it made some DNS requests. We are looking at, it's basically sending a GET request for more information. So it looks like it's trying to get something from here. This will just kind of give you everything that you're looking for. So it looks like, like I said, I didn't actually look through any of this ahead of time, so I'm having to dig through it myself too. So also, one thing to note, if a packet matches more than one specific rule, it'll typically alert you down here in multiple fields. It'll have multiple different alerts that it'll show just as a heads up. So let's see. One thing that kind of stands out about this packet, so Wireshark is, I guess, knows to decode this as HTTP because it is a semi-common port, but it is communicating HTTP over 8443. That was typically unusual. So if you don't allow that in your network, that could be a sign right there that something malicious is going on with this request, and to pay attention to that destination address. And you can use that as a pivot point to look for more, I guess, maybe hosts that might be infected, or just for other activity or communication between the different machines, or the different the malware and the command and control servers, that kind of thing. So yeah, I guess that's kind of going to be it for the looking at an alert itself. Did anyone have any questions on here by chance?
Nothing popping off the bat?
Yeah, if anyone has any questions on going through this, I know that I'm a little vague. Like I said, I didn't expect people to really want to see this, so I didn't have too much put together. And I threw a lot of this together on short notice. But if you're going through and looking through this when we get offline and you have any other questions, I have a better chance to go through and actually look at the PCAP itself. I can kind of walk you through doing different things. It turns out going through a PCAP live is a lot like trying to do math live. It doesn't go too well. But anyways, so another cool thing that you can do is, let's go ahead and clear this, just get back to our entire PCAP. If you want to get an idea of how many alerts, I guess you saw in your PCAP, it'll actually tell you here. It'll break it down by the type. So we have UDP alerts. We saw, let's see, I believe 8 packets that it alerted on. Yep, total bytes. Snort alerts on TCP, 23 alerts. So this is pretty cool if you're just trying to get an idea of how many alerts. I don't know what you would really use that for, to be honest, but it is there just in case you have an idea of what you could use it for. So yeah, let's talk about investigating alerts in a situation where you don't have full PCAP. A lot of these alerts are going to be really difficult without full PCAP. And there will be some that are going to just flat out be impossible to investigate without having a full packet capture, just because the logs and the information you're going to use are going to go back to Netflow, like we were looking at earlier. Not just Netflow, but also host logs. So you might not have all of the logging enabled to get you the full picture, whereas if you had full PCAP, you would be guaranteed to have it for those network IDS alerts. So I'm going to put you guys on mute for a quick second to get a quick drink. Okay, I didn't actually use mute, but okay, so let's talk about investigating an alert if you don't have a full packet capture, or if you don't use full packet capture. The first thing that I typically like to do is go through and look at my Netflow. This is going to be a good way for you to actually see if the connections in question really did happen. So let's say in the instance of our CNC one, I forget which alert that was. Let's see here. Let's find one. Oops. Let me reopen it. My bad. While we're waiting for that to reload. So basically, going back to that command and control traffic one on the Fiodo tracker, that one was looking for specific IP addresses. So where I would typically start with that is check my Netflow and then go through and search for the IP address that it triggered on. I would see if the connection actually was established, and then if there was any data transferred between the two. If there was, then you can safely assume that there was communication. Awesome. There was communication between the possible malicious address and the host that you might have in your network. So you'd be able to confirm that. Hold on, let me get this back open. You could also see what other hosts in your network might be talking to that address really quickly, just by seeing who else is talking to that same address. But before you go down too deep into a rabbit hole, there's some other things that you can typically check. So depending on what it's alerting on, in that case, it was a CNC server, you'd want to look up and investigate the address itself. So one of the sites that I like to use is RobText. And let's wait till we get here. All right. Let's see. I guess really we could pick any of these. I'm going to choose HTTP request on an unusual port. So I'm going to type in the address that was possibly malicious. So it's this 186 address. So that's, let's see, let's do this. Where is it? Well, I'll just type it out. That 139. This will give you a lot of good information. I'm not logged in, so I can't see some of the reverse DNS query information. It'll give you where the address is located. Like I said earlier, just because it's from the US doesn't mean it's not malicious. In this case, this IP address is a US-based address. And do know that addresses do change pretty frequently. So IP addresses aren't really a good long-term, I guess, thing to kind of correlate on, but for the short term, it'll give you an idea. And you can see who is, this is CenturyLink. This is probably not CenturyLink actually hosting it, but could be a customer that they have that might be infected, or maybe they have some sort of cloud storage and that's just part of their network. One thing to kind of keep in mind, just because an IP address is owned by Amazon or Dropbox or Google or Microsoft doesn't mean it's not malicious. Amazon has AWS. Anyone can spin up an AWS server and then have you, or basically send your data to it. Same thing with Microsoft Azure, Google Cloud, any kind of the hosting provider. So don't assume because it's owned by one of them that it's not malicious. So yeah, anyways, this gives you an idea of who owns the address, where it's physically located. Because I'm not logged in, I can't see a lot of the good information, but you'll also get a graph. This can be helpful for, I guess, seeing how things are connected. We can see that this IP address is possibly related to this domain name. And then what the AS number is, the autonomous system number that we were talking about earlier, is associated with it. These are good to keep track of, simply because you might see a lot of attacks coming from a specific AS number or autonomous system number. And that can be a pretty good indicator to kind of, I guess, remember, to help you kind of go through and correlate different attacks to try and basically build a pattern of, who's attacking you. Are they from the same group? If they're coming from the same AS number and it's one that's a smaller one, like one that's not owned by Microsoft or Google or whoever, it could be an indication that it's the same group attacking you if you repeatedly see that same autonomous system number. But anyways, this will show you how they're connected. to each other. You'll see a history. This typically, I believe, shows like a DNS history. And then, of course, the whois information. So like this will give you kind of passive DNS information and I believe some other stuff as well. To be honest, I don't remember off the top of my head. And then, so we have an IP address. We've seen who it's communicating with. Still don't 100% know if this IP address is malicious. Another thing that you can do, if you have any threat feeds or you're using any open source threat feeds or something like VirusTotal, you can, of course, go there and search it. Do be aware, you don't want to just submit everything in the world to VirusTotal. This can tip off attackers that you are investigating them. I don't know why that's not loading. Let's try this again. Also, investigating alerts without that full packet capture is kind of an art. So there are multiple ways to do this. If you have things that you want to throw in that you've done in the past that have been helpful, feel free. I'm just kind of walking you through the steps I typically take. So while we wait for that to load, so basically the next kind of step that we would go through, I would go through and look at around that time that the alert triggered, any new processes that might have established. So something cool that you can do in Wireshark and that I typically like to do is you can basically change this time column to show you a time that you, I guess, are using internally. Typically in environments, everyone will have all of their devices synced to UTC time if they're in multiple geographic time zones. That way everything can kind of stay synced and you can correlate things that may happen in different parts of the country, yet you don't have to try and figure out what time it actually happened. So I'm just going to convert this to UTC time. And let's see, time format as specified. So let's do UTC time, hit apply. Okay, so now we have the UTC time, so 17:35:53 in that really specific millisecond. So next thing I would probably do is go to whatever host that this IP address belonged to, and then look for any new processes, files, anything that may have been created around this time frame. The amount of time before that is obviously going to be dependent on the attack itself. As you can see from this packet capture.
What would you be using to look for processes?
So that's really going to be dependent on the tool set that you have. The best place to look is your Windows event logs. You should be sending your Windows event logs to a remote like syslog server, like an ELK instance or a SIM. I know, unfortunately, that's not always the case and it's not always that easy. So if you don't have the ability to do that, you will have to either connect to the machine itself remotely and then kind of go through them and search through them, which is a huge pain. Yeah, I mean, that's probably the best way to do it. If you have like more advanced tools like a Carbon Black or some sort of like host intrusion detection system like an OSSEC, you may actually have an alert for every new process that's created. You can just go through and search for that. But yeah, so anyways, go through, look for any new processes created around that time frame. I think the alert that I specifically looked at before was a good bit before or after this, I think like within 6 minutes. So I typically would go back and search. I think I normally do like 30 minutes to start off with. But sometimes you got to go back further because these signatures or because these Snort alerts are signature based. Just because it alerted at a certain time doesn't mean that it was just then like a new thing that's happened. It could have been in your network for a while and a new signature gets updated and it just started alerting on it. So that's something that you got to kind of keep in mind. Something else that you can do is do a netstat and to look at all of the network connections that may be going on a host, and then identifying what the host is communicating out to. So let's say we want to see one that's actually connected to here. I forget what it is in Linux. Jeff, you might know. Is it still just netstat?
It is. The switches are a little bit different, but it is still netstat.
Let's see. Let's do.
ALN will list all and won't resolve them for names.
Okay, cool. Let's do this. Adding the less command, for those of you that aren't familiar with Linux, if you had that pipe, you're basically saying also run this command after, or I guess in conjunction. Maybe you can clarify that more, Jeff. I'm not a Linux guru myself.
It's take the stream of data and run it through this program.
Exactly. And what less will do, where it just kind of flooded my screen, it'll basically say, it'll fill your terminal and then it'll stop, and you can press enter to go down one single line or spacebar to go down a few. It'll make it a lot more readable. But from here, we can go through and see all of the addresses we're communicating with, the state, if they're established, if it's just listening. So in some cases, malware may not actually be communicating, but it may be listening on a certain port for different commands. And this can identify, hey, yes, this machine is talking to that host. So we do know that, it did catch whatever we were searching for. So let's go back to VirusTotal. Now, I'm going to search the IP address you're looking for now that this is loaded. And in this case, there are no matches. That's interesting. Let's do one that might have a match. Let's try another one. So let's again do Snort. Let's try the 73 address. There we go. 73, 125, 45, 48. Here we go. Still not much better. So as you can see, your threat feeds will not always help you. So all we know at this point is that we have a Snort alert that's triggered. We've confirmed it was a true positive because we looked at the alert and we saw what it was looking for. In the case of this particular one, we know that it was just looking for any of our internal addresses talking to this specific address right here, the 73, 125, 48, 80, or 48 on port 80. So we know that that's something that our host might be communicating with. So if you run a netstat, we see it on there. We say, hey, yes, this is live. So now you need to figure out what process that's associated with. Doing that is going to be a little bit more tricky. I believe in Windows, there are some netstat commands that will actually show you the process that's assigned to whatever network connection that has been made.
You can also do that in Linux. It's just a different set of them.
What's the switches?
I'd netstat -help and see, because they are different between Windows and Linux. But yes, E extended. No, not E. E is on Windows.
I can never remember them. So let's see here. Let's look for
P is program.
Yep, here it is too.
E is extended display more information. You want both of those.
Yeah, so let's go back. ELN, let's add P. So now, let's add less to that again so we can read it easier. So we have the state. This is the user in Linux or Unix environments. The user is assigned a number. I'll have to go back and kind of look up how to figure out what user is assigned to which user number.
You would look in groups and user or groups or password or groups. And oftentimes the higher the number is a non-privileged user.
Okay, there you go. And then we can see Chrome. So now we've identified the process with it. At that point, there's a lot of different things that you can do. If you're pretty confident, say, hey, this matched. I have a confirmation I wasn't able to pull up anything on Wireshark because, to be honest, a lot of times, guys, you're not going to find something in your threat feeds for some of these signatures. So don't rely on it just because it's not in VirusTotal or Alien Vault's Open Threat Exchange or whatever else that you might use. Doesn't mean it's not malicious. That's another kind of thing that a lot of people fall into a trap to. They look it up, they say, whatever, they just brush it off. You can also do this netstack command remotely if you have the administrative privileges on Windows and Linux, or if you have certain tools. So like Google has a tool called GUR, which you can load on different computers that you can remotely pull all of the network connections and processes associated with them, as well as the memory remotely. And that's a free tool that anybody can use. So what I would probably typically do is pull memory from the workstation and then extract the binary with like volatility or whatever it might be. That's going to be kind of out of scope for what we're talking about today. And then from there, you can kind of look at the binary to see what exactly it's doing, just by doing some either reversing, throwing it in a cuckoo sandbox locally, whatever it may be. I do want to, again, stress, anytime you upload a file to VirusTotal, it does make that file public. So if they have like a paid VirusTotal account and you upload something that, let's see, what's something we can upload? Here, let's just open the PCAP. Yep. So we're going to hit OK. It's going to scan the file. Anyone that has a paid VirusTotal subscription can go through and not only download this file and see everything in it, but they could also tip off the attacker that you are doing research on them. That may or may not be something that you want to do, depending on your job role and the type of work your company does. You want to probably have a policy defined ahead of time, or check to see if there is one, to see if it is okay to submit things to VirusTotal. Same thing with malware, which is another open source sandbox.
Are they back?
I guess not. So let's do hybrid. What is it? Analysis, I think. If you submit it to hybrid analysis, if it does detect a true positive on here, it will automatically submit it to VirusTotal, just as a heads up.
So if you've got if you think it's a spear phishing campaign against your organization, you may not want to submit it out to that, because it would be particular to you as opposed to everyone else.
Yeah, exactly. And also, if you have a file or even a program that you're not sure what it's doing, you may inadvertently upload something to VirusTotal or whatever the sandbox is that you've uploaded it to that could have company-specific information that may not be malicious. So say you get an email from whatever at gmail.com and it said like, hey, I'm Jeff from accounting. I'm working from home today. Open this spreadsheet for the payroll, whatever it might be. That doesn't necessarily mean it's malicious. So it's one of those things. Be careful what you upload to here. There's some other things that you can do to kind of look into.
I've actually done that before, and we got alerted to a phishing email that turned out to be something sent from a copier, and it had PII on it. And we uploaded it to VirusTotal.
Yeah.
And that was fun.
Yeah, there are people. Oops, sorry, I didn't mean to cut you off.
No, it really was a process to go through with VirusTotal to get that removed from there. And
yeah. And there are people, if you have the paid VirusTotal like account, you can basically have it search and query everything that's uploaded VirusTotal for specific strings or like regex or whatever it might be. So if you upload a spreadsheet that's full of social security numbers, chances are someone's got a rule that's looking for social security numbers and they'll automatically download that file. And boom, you just uploaded maybe your entire company's socials or like payment information, passwords internally. I don't know why you would have those in a spreadsheet, but who knows? Email addresses that could be sensitive and not public, whatever it might be. So that's one way you can investigate an alert without having the full PCAP. If it's something that's not like a typical host, like a Windows host or something that might not be malware related, like let's say you receive an exploit alert or a buffer overflow alert with Snort. Those are going to be a lot more difficult to investigate. because it's going to affect that specific application itself. And typically what you'll need to do is investigate that specific application that it was targeting's logs to see if anything was, actually changed or done with that application. So did the application crash at the same time you got that buffer overflow alert? Was maybe, I don't know, a new process created, new something done to it? Look for basically changes within that specific application. And that can be hard to do because if you're not an expert in the application, you might have to work with somebody else and it can be frustrating. So or depending on internal company politics, can be almost impossible. And then again, there's also alerts, and I saw this in here somewhere. Let me find it. Some of these rules too that you get can be extremely vague or just poorly written or whatever it might be. Here's an example of one that has multiple snort rules in it. They don't always expand. I'm not sure why. But here we see we got an alert and executable over HTTP. Typically bad. You don't see that very often anymore. So if you do see it, I would say more often than not these days, it's probably malicious. So let's see. There was one I saw earlier I want to look at. Let's see. Don't remember the SID on it. Here we go. So this right here, generic suspicious post to a dotted quad with fake browser. I have zero idea what that means. So let's see what it's looking for. So it is looking, this is where it's basically matching. So basically it's saying it has to be a post. If it's not a post, it's just going to ignore the packet outright. And then next it's going to look for this. If it has this in the field, it's negated, meaning it's not looking for this. So it's going to ignore any that match this. It's looking for MSIE. No case means basically it could be lowercase as well and still trigger. Fast pattern basically means that if this is not here, it stops the alert and just continues on versus continuing to check down. So if this is not present, it's going to just discard the rule, go run it against the next one. So it's looking for except encoding, this line right here. And again, negated. So if it has that, it's taking it out. If it has, oh, I should mention too, if you see these pipes, like pipe 3A, this is specific hex. So it's looking for a string that says except encoding followed by the hex 3A. And I'll kind of show you how to look at that in a second. Again, negated for this field, negated. So what exactly are we looking for? And of course, it's got some really complicated regex. If you're not good at regex, a really good tool that I like to use.
Talk to Ralph. Ralph knows regex.
Yeah.
Your guy. Just ping him. He'll be good with it.
Yeah, you can also go to regex 101 and just copy and paste it in there. So PCRE, that's what Snort uses. As you can see, it has it right here, PCRE. So you can copy this value. So, oops, paste it into here. And it will give you an explanation of everything it looks for. This one's really complicated. I'm not going to kind of walk through the whole thing. So kind of what I'm getting at here is I look at snort rules and alerts really frequently, and there's still some that I get that I have a hard time identifying. So don't get discouraged by that, especially at first. But one of the ways that you can get around that, if you ever just can't find a snort alert in a packet capture, see if you can get permission to stand up an Ubuntu instance like this, and then use this kind of snort integration trick that I showed you. So if you get an alert, now, hey, we found the exact packet that this matched on. So maybe we couldn't figure this out, but we still got the packet. So now we can see what exactly in that packet it was firing on. So let's go to follow TCP stream. And I have a feeling it was on one of these user agent fields. So it was looking for MSIE 7.0. I'm still not 100% sure what it was looking for. So let's do this. Let's take this user agent. Let's copy. And where we had that regex buddy, paste it in here. No match. You know what? Let's do this. Let's just copy this entire stream and see what exactly it did fire on. One match. Highlighted in blue. Oh, okay. Well, so that's what it fired on. That in itself, to me, is not malicious. That's just saying the IP address of the server that it connected to. I'm really surprised that it triggered on that, so I'm not sure why it did.
Oftentimes hosts get categorized as bad and never be taken off an unbad list.
Yeah, exactly. So there you go. In that particular instance, I mean, that's just probably a bad rule, in my opinion. That's something that I would most likely disable in my environment, but everyone's different, and that might be something you want to look for.
So do you want to do like a 5-minute summary and a finish up? Because I think we're probably getting close to the end of what we can do at this point.
Oh, yeah, sorry. I haven't been keeping track of time.
No, that's okay. This has been great information, and I don't want to stop it, but I do know that
people got to go. So, yeah, I guess kind of in summary, this kind of Wireshark Snort integration is really what I wanted to show off. You can see how easy it makes looking up Snort rules and alerts, and even Suricata rules if you're using the emerging threats rule set. Or if you're not using either and you just want to run your PCAP against another IDS, well, this gives you an option to do that and to give you a way to view all of the alerts related to it, to kind of give you a second correlation to build off of. We also kind of talked about, you know, how full packet capture is typically done in a big environment, how you can use Netflow and some examples, and how to investigate alerts. There's a whole bunch you can kind of do on these as far as investigating things that you might not have full packet capture for. The best thing I can say is try and get Netflow, try and get your host logs, forwarding to an elk stack or something. Elk is totally free, by the way. I do want to show one other quick thing. If you go to, if you run elk in your own environment and you're trying to get Windows logs into it, Malware Archaeology has some cool cheat sheets, and it has Windows logging cheat sheets that'll tell you exactly how to enable everything, as well as what kind of logs you want to enable.
That's a great resource.
It's super great because most of these are disabled by default. And not only that, but they have tools you can do or use to basically configure. I guess it's still under here somewhere. Let's see. No. Basically, they have tools and files that you can use in your environment to. Hold on, sorry. Basically, if you don't either have the technical know-how or you don't want to have to go through and do that manually on all your machines, they have scripts that will go through and automatically configure your host to do the advanced auditing, the regular file and registry auditing. I don't know why you want to clear out the logs. Processes that you should monitor, that kind of stuff. But really the cool thing is the WinLog beat. This is what ships Windows event logs to Elk. They have a configuration file that you can push out. You still need to do some configuration on that to use it in your environment. Like, for example, putting in your host ID, or not your host, but your Elk IP address. But I mean, it'll actually automatically collect everything that is shown in this cheat sheet. So it'll collect those logs, forward it to your Elk stack, and on top of that, it has a whitelist, so things that are just generally noisy. So whenever you're investigating processes like we were talking about earlier, a lot of things like Chrome, whatever it might be, you're going to see new processes spawn all the time. This went through and whitelisted a lot of the most common ones that are typically not malicious. But anyways, I don't want to go too far in that rabbit hole either. This is a great resource, malwarearchaeology.com. So definitely make use of that. Can help big time for investigating alerts. And if any of you guys have anything that you want to see after this, maybe you got lost and you just want to follow along after just questions, feel free to ping me on Slack. I don't mind walking you through individually on this one-on-one if I have the time to do that. So yeah, just message me if you have any questions. And on that note, does anybody have any questions?
I would say that if you have a question, other people probably have that question as well. So put it into Slack. If you're not on Slack, we can get you on there. If not, shoot it to the email list. If you have questions, please unmute yourself and go ahead and ask some.
Yeah. And if you got lost along the way or just I was going too fast, just ping me after this so we can set up a time and maybe I can just walk through some of the stuff again with you one-on-one. I don't mind doing that. I just have to schedule it out.
And Corey does have the recording that he'll put out on YouTube. It'll be on our Colasec YouTube page. So if you need to go back and look at any of it, feel free to do that as well.
Yep.
I just want to jump out there and say thank you so much, David, for putting all that effort out. I really appreciate it.
I really wasn't.
Absolutely.
It really wasn't all that much. I put everything together today.
You did a good job.
Well, you've been working on this for a while. I've seen your posts in other places. This isn't a today thing. This is a few weeks of work that have culminated in what you put together for today. So
yeah,
don't sell yourself short.
For those of you that don't know, I came across this Wireshark integration on accident, just looking for ways to kind of automate finding rules within Wireshark for Snort Alerts. And I came across this and was like, I've never heard of this before. No one's ever mentioned this ever on any of the classes I've ever taken. Never seen any posts about it. If you look on Google, it's not even very well documented. I do want to show you one last thing, actually. Sorry. So there is some very, very weak documentation. If you want to get some filters that you can use, here's all of them that you can search for in Wireshark. So yeah, I mean,
Nice.
They have it documented. It shows you the versions of Wireshark you need. But yeah, it was a real pain to figure out how to get this to work, and it ended up being super easy once I figured out what was causing the problems. But anyways, yeah, if you have any questions, feel free to ping me whenever.
No, we appreciate it, and this is what we want. If anybody else has ever come across something like this or something that they want to talk about, we highly encourage this kind of community. So thank you, David. I appreciate it.
Appreciated.
Yeah, no problem. And again,
Yeah, thanks a lot, man. Appreciate it.
Yeah, no problem. Feel free to ping me if you have any questions.
And good night. Thanks, everybody.
Y'all have a good one.
Thank you. Good night.
Yep, adios.